Congratulations, you've made it to our last unit in Accelerated Algebra 1 in Geometry. Our last unit is on right triangle trigonometry. So right triangle trig involves three new vocabulary words: sine, cosine, and tangent. We abbreviate sine with SIN, cosine with COS, and tangent with tan. Do not say tan, cos, and sin. You want to sound like a mathematician, so sine, cosine, tangent. So it says for any acute angle in a right triangle, we denote a measure by the angle theta, alpha, or beta, and define the ratios related to theta as follows. So when I have a triangle here is my angle theta. This side right here is a side that is adjacent to theta. Adjacent means next to. So this is a side that is next to theta. This side is not adjacent. This side is the hypotenuse. The hypotenuse of a triangle is always the longest side, and the hypotenuse is always across from the 90-degree angle. This side over here is opposite of theta. So to find sine of theta, to do that we would do the opposite side over the hypotenuse. Hypotenuse, there we go. So we would take this side length and divide it by this side length. For cosine of theta, we do the adjacent side over the hypotenuse. And for tangent of theta, we do opposite over adjacent. In math, there's a saying to help you remember these ratios. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So to remember this, we say something called SOHCAHTOA. And all it stands for is sine is opposite over hypotenuse, cosine is adjacent over the hypotenuse, and tangent is opposite over adjacent. If you look at the last page of your notes, you'll see this graphic organizer, and this can help you see all the angles here if you want to use theta. Oh, this one is up here, and so is this one. So sine for this angle would be the opposite over the hypotenuse. Cosine for this angle would be adjacent over the hypotenuse, and tangent of this angle would be opposite over adjacent. So this graphic organizer can help you while you're completing these problems. So if we go back to this page, it says use the Pythagorean theorem. Remember that the Pythagorean theorem is a squared plus b squared equals c squared. So use the Pythagorean theorem to find x, the measure of the leg opposite of theta. So they're telling me that this is the opposite side, and I can see that. So this 7 would be the adjacent side, and this 9 is the hypotenuse. Hypotenuse is always the longest side, and it's always opposite the 90-degree angle. So here I'm going to let 7 be A, x is B, and 9 is C. Remember, your hypotenuse is always C. So to use the Pythagorean theorem, I'm going to do 7 squared plus x squared equals 9 squared. So I'm going to have 49 plus x squared equals 81. Well, to solve for x, I can go ahead and subtract 49 from both sides. And when I do that, I get x squared equals 32. Well, here I have a quadratic equation, and we learned how to solve quadratic equations back in Unit 4. Here, the best way to solve this one would be by taking square roots. So to undo the square, I'm going to take the square root of both sides. I'm of x equals, whenever we take the square root of a number, it's always plus or minus. And to simplify the square root of 32, I'm going to use the birthday cake method. The smallest prime number that goes into 32 is 2. It goes in 16 times. The smallest prime number that goes into 16 is 2. It goes in 8 times. 2 goes into 8 4 times. 2 goes into 4 2 times. And 2 goes into itself once. So I have these pairs of 2's and these pairs of 2's. I get to leave the square root symbol. 2 times 2 is 4. This 2 doesn't have a pair, so that 2 stays inside. So I have two answers here. Positive 4 square roots of 2 and negative 4 square roots of 2. And we need to figure out what makes sense for this problem. Well, this is a side length. Can I have a negative side length? No. So here, x is only going to equal the positive. So here, x will be 4 square roots of 2. So that is this side length right here. Part B says find the values of the three trigonometric ratios. When they're talking about the ratios, they're asking for the fractions. So let's start off with sine. Remember here we're using SOHCAHTOA. So sine of angle theta is going to be opposite over hypotenuse. The opposite is 4 square roots of 2. The hypotenuse is 9. This is the ratio for sine. Next, I'm going to look at cosine of theta. Cosine is adjacent over hypotenuse. Adjacent to angle theta is 7. The hypotenuse is 9. The last trigonometric ratio we're going to look at is tangent of theta. Tangent is opposite over adjacent. Opposite of theta is 4 square roots of 2. Adjacent to angle theta is 7. These are my three trig ratios for this triangle. Often you will be given a measure of angle theta. So like this right here could be like 30 degrees or 72 degrees or whatever. And we need to calculate that number. To do that, your calculator has to be in degree mode. This is very important. If you're using a calculator app like Calculate 84, that has this option in there where you can go ahead and download that. It's a free app. And when you do that, oops, let's see. To do that, you click on Mode, and then you scroll down to where it says Radiant Degree, and you want that degree to be highlighted. Once it's blinking, go ahead and hit enter, and now degree is highlighted just like how it shows it here. Because we're calculating in degrees, we're not calculated in radians. Radians is another type of unit, and you'll go more deep into that in pre-calculus. So now I'm going to quit out of here, and now I am in degree mode. So it says we will now practice finding a missing side length given theta and one known side length. Remember to label opposite, adjacent, and hypotenuse to determine which trigonometric ratio to use. So again, we're going to be using SOHCAHTOA here. And here we're finding a missing side. So it says use the appropriate ratio to write and solve an equation to find the missing side length. Round to the nearest tenths place. Alright, so here is my angle theta that they gave me. So here I can see that 4 is the hypotenuse because it's opposite the 90-degree angle. And x is next to 51, so this is the adjacent side. So which one of these three ratios uses adjacent and hypotenuse? The only one that uses both adjacent and hypotenuse is cosine. So here we're going to be using the cosine function. So cosine, and then instead of saying theta, I'm going to say my angle number. So the angle is 51 degrees, and that is going to equal my adjacent side over my hypotenuse. This is an equation that we can solve for x. Pretend over here is just a number and doesn't involve the cosine. How would you undo this division? Multiplication. So to undo this division, I'm going to multiply both sides by 4. So I'm going to have 4 times the cosine of 51 is equal to x. This is a number that we can calculate in our calculator, and this is why we put our calculator in degrees mode. So in my calculator, I'm going to do 4 times cosine of 51. And when I do that, I'm going to hit enter. They told me to round to the nearest tens spot. The tens place is the first decimal after the first place after the decimal spot. So I look at the second place. If that's 5 or higher, I round up. If it's less than 5, I round down, or I keep it the same. So here my number is going to be 2.5. So x is 2.5. So this missing side length right here is 2.5. Let's try another one. So here the angle they give me is 65. On the opposite side of 60 side is x, and then this 21 is the hypotenuse because it is opposite the 90-degree angle. So if I'm looking at SOHCAHTOA, which trig ratio uses opposite and hypotenuse? Well, that's going to be sine. So I'm going to say sine of 65 degrees is equal to the opposite side over the hypotenuse. From here, I can solve for x just like we did in the last one. X is being divided by 21. To undo division, I'm going to do multiplication. So I'm going to have 21 times the sine of 65, and that's going to equal x. To solve for x, I can just plug this part in my calculator. So 21 times the sine of 65, and I get 19.0. I am going to include the 0.0 because they told me to round to the nearest tenths. It doesn't end at 19. There is a decimal spot after that, so I want them to know that I am rounding here. Now that you've seen both A and B, go ahead and pause the video and see what you can do on C and D. Alright, so the angle they give me is 78 degrees. Adjacent to 78 degrees is 4. The opposite side is blank. And the hypotenuse is x. So, which trig ratio uses adjacent and hypotenuse? Well, that's cosine. So I'm going to have cosine of 78 equals 4 over x. Well, this one's a little bit different because I can't solve for x if it's in the denominator. So, to get rid of the denominator, I'm going to have to multiply both sides by x. So I'm going to have x times cosine of 78 is equal to 4. Well, now x is being multiplied by cosine of 78. So to undo multiplication, I'm going to do division. And so I'm going to have x equals 4 over the cosine of 78. This is something that I can plug into my calculator. So I'm going to do 4 divided by the cosine of 78 degrees. And when I do that, whoops, oh, I had too many parentheses there. So 4 divided by cosine of 78, and I get 19.2. So 19.2 is this side length. This one, D, is very similar to C, so go ahead and pause the video and see if you can do that one. So now my degree is 24 degrees. Opposite of 24 degrees is 9. Adjacent to 49 degrees is x. So which trig ratio uses opposite and adjacent? Tangent. So I'm going to say the tangent of 24 degrees is equal to the opposite over the adjacent. I can't solve for x if it is in the denominator. So I'm going to begin by multiplying both sides by x. So I'm going to have x times tangent of 24 is equal to 9. X is no longer in the denominator, so I solved that problem. X is being multiplied by tangent of 24. To solve for x means I need to get x completely alone. So to undo multiplication, I'm going to use division. When I do that, these cancel, and I get x equals 9 over the tangent of 24. So on my calculator, I'm going to do 9 divided by tangent of 24. Oops, I did it again. 9 divided by tangent of 24. And I get 20.2. So you've just completed 4 examples of finding a missing side using trigonometry. Now that we've looked at finding a missing side, now we're going to look at finding a missing angle. So here it says an airport is tracking the path of one of its incoming flights. The distance to the plane is 850 feet. So we can see that right here. The altitude of the plane is 400 feet. So we can see that right here. What is the sine ratio of the angle of elevation from the ground at the airport to the plane? Refer to the figure. So here we're looking for this angle right here. And opposite of this angle is 400 feet. And then this would be a 90-degree angle here because this is perpendicular to the ground. So this one is the hypotenuse, which means that this side is the adjacent side. So to find sine, remember we're using SOHCAHTOA. Sine of theta is going to be opposite over the hypotenuse. So 400 over 850. They just asked for the ratio. The ratio means a fraction, so that's all I have to do for this one. If you want to reduce this, you absolutely could. So if we look at part B, it says, what is the cosine ratio of the angle of elevation? Hint, use the Pythagorean theorem to solve for the missing side length right before setting up the ratio. So cosine of theta is going to be adjacent over the hypotenuse, right? Well, we know the hypotenuse is 850. We don't know the adjacent side. That's why it's telling us to use the Pythagorean theorem. So remember the Pythagorean theorem is a squared plus b squared equals c squared. So if I call this side x, that means I would have x squared plus 400 squared equals 850 squared. Remember, a and b are always your legs, and c is always your hypotenuse. So now I'm going to have x squared plus, let me clear this out a little bit, 400 squared is 160,000, and 850 squared is 722,500. Again, I have a quadratic equation. I don't have a b term, so the best way to solve this one will be to solve by taking square roots. So I'm going to subtract 160,000 from both sides and get x squared equals 562,500. And then to undo the square, I can take the square root. Because we're talking about side lengths, I'm not going to use plus or minus because it doesn't make sense to have a negative side length, especially in this situation. So let's see if this is a perfect square. If it's not a perfect square, we're going to have to estimate, because it wouldn't make sense to use square roots in this situation either. Oh, 750. Perfect. It is a perfect square. So that means that this length right here is 750 feet. So that is my adjacent side. So 750 over 850 is my ratio for the cosine of theta. If you wanted to reduce this, you could. Part C. What is the tangent ratio of the angle of elevation? Well, so tangent of angle theta is going to be opposite over adjacent. So my opposite is 400 and my adjacent is 750. So again, they asked for the ratio. Here is the ratio. If you wanted to reduce this, you could. So in the last 4 problems that we did on the previous page, we were finding a missing side length. On these next ones, what we're going to do is we're going to find the angle of theta. And to do that, you're going to use the second button on your calculator. So it says now use your calculator to find the measure of the angle itself. Pressing the second button followed by one of the trigonometric function keys finds the angle measure corresponding to the given ratio. So then it tells you exactly what to do to find theta from our sine ratio. So to do this in our calculator, clear everything out again. I'm going to hit the second button and then I'm going to hit sine. And what that does is changes this to the inverse of sine. So the inverse of sine, and now we plug in our ratio. So our ratio for sine was 400 divided by 850. When I hit enter, let me fix this here. I'm going to get the angle. So I'm going to get something in degrees. And I get 28.07 degrees. They tell me to round to 2 decimal places. So again, when we plug this in our calculator, we did the inverse of sine, and we used our ratio, which was 400 over 850. And when we did that, we got 28.07 degrees. Make sure you include your degree symbol. Now we want to do the same thing for cosine. So we're going to do the inverse of cosine, and then our cosine ratio that we got on part B was 750 over 850. So now I'm going to do that in my calculator. So second cosine 750 divided by 850. And I get 28.07 degrees. Now we're going to do the same thing for tangent. So we're going to do the inverse of tangent, and the ratio for tangent was 400 divided by 750. So second tangent, 400 divided by 750. Oops. And again, we get 28.07 degrees. So, when you're finding the side length, like how we did on the other page, that's when you just use sine, cosine, and tangent. When you're finding an angle measure, that's where you're going to use the inverse of sine, the inverse of cosine, and the inverse of tangent. Part G. What do you notice about your answers in D through F? Why is this true? So go back to the other answers that we just went over together, and I want you to figure out what you notice about those answers. So you should notice that all the answers are the same. Why is this true? Well, if I look back at the problem, no matter if I use sine, cosine, or tangent, I'm still solving for theta. Theta is this angle for every single one of them. So why are they the same? Well, I'm finding the same angle, the same triangle. That's why it's all the same. So whenever you're trying to do this and you could use more than one, either sine, cosine, or tangent, you just pick whichever one you like the best. So this is because it's the same angle of the same triangle. To the nearest hundredth of a degree, so 2 decimal places, what is the measure of angle of elevation? Well, that was 28.07 degrees. That was what we got for all three of them. Note that an angle of elevation is measured up from the horizontal because to look up at something, you need to raise or elevate your line of sight to the horizontal. So an angle of elevation is going to be something like this. An angle of depression is measured down from the horizontal because to look down at something, you need to lower or depress your line of sight to the horizontal. So, oops. This would be an angle of depression. So angle of elevation, you're looking up. Angle of depression, you're looking down. The top of a billboard, you can see my beautiful billboard right here, is 40 feet above the ground. So this height is 40 feet. What is the angle of elevation? So that's going to be theta of the sun when the billboard casts a 30-foot shadow. So we're talking about this part right here. This is the shadow. So 30 feet, just this part over here. This would be a 90-degree angle. Sketch a figure to illustrate the problem. So here you can see my beautiful picture. And now, if we scroll down, it says use the inverse trigonometric function to find the angle of elevation round to the nearest hundredth of a degree. So let's think about this logically here. Opposite of theta is my 40 feet. Adjacent to theta is 30 feet. Which trig ratio uses opposite over adjacent? Well, tangent uses that. So here we know that the tangent of theta is going to be the opposite over the adjacent. I want to find this angle measure. So to do that, I have to use my inverse trig ratio. So I'm going to say the inverse of tangent of 40 over 30. And that's going to give me the measure of angle theta. So in my calculator, I'm going to do second tangent 40 divided by 30, and I get 53.13 degrees. So this is this degree measure right here, 53.13 degrees. Do not forget your degree symbol. For problems 2 through 5, find the missing angle. So here we're finding an angle, not a side length. Round to the nearest hundredth of a degree. So, on number 2, here is my angle alpha. Next to alpha is 9, so that's adjacent. Opposite of alpha is 5. So if we're using SOHCAHTOA, which one uses opposite and adjacent? Well, tangent. So I'm going to have the tangent of alpha, ooh, that's a weird looking alpha, is equal to 5 over 9. Well, to find alpha, I have to do the inverse. So the inverse of tangent over 5/9 will give me the angle for alpha. So in my calculator, second tangent, oops, so second tangent, 5 divided by 9. I don't know why my calculator is not agreeing with me today. When you do this in your calculator, you get 29.05 degrees. So this is the measure of angle alpha. What I'd like you to do is go ahead and pause the video and find the measure of angle beta. So for beta, opposite of beta is 7, and then the hypotenuse is 24. This is the hypotenuse because it is opposite the 90-degree angle and it is the longest side. So the trig ratio that uses opposite and hypotenuse is sine. So to find beta, I'm going to have to do the inverse of sine. And my ratio for sine is opposite over adjacent. And when you do that in your calculator, you get that beta is 16.96 degrees. Go ahead and pause the video and do 4 and 5. On number 4, this is my angle alpha. Adjacent to alpha is 3, and then the hypotenuse is 5. Adjacent and hypotenuse, well, I'm going to use cosine for that. So I'm going to do the inverse of cosine, adjacent over hypotenuse. And when I do this on my calculator, it gives me the measure of angle alpha. And when you do this, you should get 53.13 degrees. On number 5, here's my angle beta. Adjacent to beta is 6, and then 17 is opposite the right angle, so that is the hypotenuse. So adjacent and hypotenuse, well, I'm going to use cosine again. Because I'm finding an angle measure, I have to use the inverse. So the inverse of cosine of 6 over 17. And when you plug this into your calculator, you get 69.33 degrees. Go ahead and work on the practice problems. As you have questions on this, please let me know. Either send me a message on Schoology or send me an email and I will be happy to help you.